Good morning everyone. In this video lecture, we will understand how to draw the isometric view or how to take the isometric projection. So basically isometric view is a three-dimensional view of an object. It is also called as a pictorial view. So if you refer the orthographic projection, in the orthographic projection, we observe in the perpendicular direction to the vertical plane or horizontal plane. So take the simple example of a cube. So here I have taken the cube. There is a vertical plane which is the drawing paper which is behind the plane, and if you observe in this direction which is a perpendicular to the plane, then we can see only this square which is the front view. Okay, so this square, it is the two-dimensional view of this object. So in the isometric projection, the basic concept is all three major axes or the major planes of an object must be visible, so that object will look like as a three-dimensional. Okay, so if you want to make this object to look like as a three-dimensional, I have to just rotate this object in this direction. Okay, so in this condition, all three major axes are visible. So if you take this x-axis, this is the y-axis, and this is the z-axis. Okay, but still, if I project this on this plane, which is a drawing paper, the object will not look like as a three-dimensional. Okay, so for this, again I will rotate this object by fixing this corner. Okay, so this corner will be the origin. So if I fix this corner and if I rotate the object in this direction, so right now we can see the three-dimensional view of an object. So this view, this is called as the isometric view or the isometric projection. So here object look like as a three-dimensional. Okay, so when we draw the any object in the isometric projection, we will fix this corner. So if I take the projection of this corner point, so this is the projection. From this point, we will draw the projection for this line. Okay, so actually this line, it is inclined to both the planes HP and VP. But if I take the projection, the line will just appear as a straight line. So from this corner, I will draw this straight line, which is a parallel to the XY line, and this angle after the projection, it will appear as a 30 degree. This is not the true angle, this is the apparent angle. Okay, this line will just appear as a straight line. Again this line will appear as a straight line at an angle 30 degree. Okay, so all these major axes, it will be at an angle 30 degree, and this axis will be at an angle 30 degree. Okay, and this axis, its angle, it is 90 minus 30, so this angle will be 60 degree. Okay, so actually this is a 90 degree. Okay, but this 90 degree, it is converted into 60 degree after taking the projection. So if I draw the projection, so this is your reference line, then this is your vertical axis of an object, then from this 30 degree we will draw the line. So this line at an angle 30 degree, and again at an angle 30 degree draw the third line. So this is your x-axis. So if you observe this diagram, this is the x-axis, this is the y-axis, and this is the z-axis. Okay, so if you complete this, so here all three major axes are visible of an object. At the same time, all three major planes of the object are visible. So if you consider this plane, this is visible in the front view. This top plane, it is visible from the top view, and this plane right now, it is visible from the left hand side view. So in a three dimension, if you observe this object, this plane will give the front view, this plane will give the top view, and this plane will give the left hand side. Okay, so this is the basic concept of an isometric projection or the isometric view. Now let us take this simple object where 2D views are given. So these are orthographic views. So this is the orthographic view for an cube. So front view is a square, even the side view is a square, and the side is a 40 mm. Okay. So to start the isometric projection, we will fix one point. This is the corner of the cube or the bounding box. From this point, draw horizontal line. This line will be a reference axis. From this point, draw vertical line. This is y, and at an angle 30 degree, so take this angle 30 degree, this is for x axis, and from this side again take the angle 30 degree. So this is for z axis. Now just draw a thin line before drawing the actual visible line. Now refer the dimension, it is a 40 mm. Okay. So this is a front view and this is side view, but the side view it is on the right side, so it must be left hand side. Okay. So now we have to decide what is the position of observer. So if this is the position of observer in the front view, then this will give the left hand side. So this is the correct position of the observer. Now refer the dimension, it is 40. So this line must be 40, again the height is 40. So from this corner, draw the line of 40 mm. Then along y direction, again the height is 40 mm. Then draw the parallel line. So this is 40, and draw the parallel line like this. So we have completed the front view. So this is the visible outline in the front view. Now in the side view, again we observe the square with the same dimension. So this is the width in the side view. So this is 40 mm. Now from this line, you can draw the parallel line. And from this line, draw the parallel line. So this is a visible outline in the left hand side view, and then you can complete the top view. So top view will be a square only. Okay, so this is a three-dimensional or the isometric view for the cube. So where this angle is a 30 degree and this angle is 30 degree. Now refer the second example. So this is the front view and this is the top view. So when we start the isometric projection, first observe the maximum length and maximum height of the front view and the top view. So if you observe this front view, the maximum length is, this is 20, 60 and 20, so it is 100 mm, and this height, so take this 20 and this is 30. So height is 30 plus 20, it is 50 mm. Okay. Now first draw the bounding box. So fix one point which is the origin, draw one reference line. Now from this corner, take the angle 30 degree on both the sides. So this may be x-axis, this is z-axis, and this is the y-axis. Okay. Now we can assume this is the observer in the front view, this is the observer in the top view, and right now the side view visible, it is from the left hand side view. If front view and top view is given, you can assume this is the front view or this is the front view. Okay. Now observe the maximum dimension in the front view and the top view. So this total length is 100 mm, height is 50 mm. So draw one reference rectangle, which is the bounding rectangle in the front view. So take the height 50 mm. Then from this line, draw the parallel line. Now this total length is 100 mm. So from this line, draw the vertical line. So this is the bounding rectangle in the front view. Similarly, if you observe in the top view, the maximum dimension is width is 30 and length is same, which is 100 mm. So from this axis, draw the parallel line from this corner point and take the length that is equal to the width in the front view. So it is 30 mm. So this is the width in the front view, sorry, in the top view. And from this line, draw the parallel line. You can directly take the length 100 mm or you can draw the parallel line which will pass through this corner. So this is the bounding rectangle in the top view. And then complete the cuboid. So here we have completed the bounding box of the isometric view. Now we can start the actual drawing. So if you observe this complete line, it is visible in the front view, which is a base line. So this line of 100 mm is completely visible to the observer from the front view. From this corner, we can take this height. So this height, this is equal to 20 mm. So along this direction, take 20 mm. Again from this corner, height is same, this is 20 mm. Now we have to draw this line, which is 20 mm. So from this line, you can draw the parallel line and take the distance 20 mm. From this corner, again take 20 mm. Then draw this vertical line, the height is 30 mm. So this line will intersect this line, which is the edge of the cuboid. Okay, so this is the front view. Now refer the top view. So in the top view, again the